Hello everyone. In this video, we'll discuss today's Leetcode daily challenge, concatenation of consecutive binary numbers. So in this question, what we are given a number n, and we have to find the binary representation of the numbers 1 to n, concatenate them, and find the decimal value of that particular binary representation. So what I am saying, let's suppose we are given a number 3. So we are given a number 3. We find the binary representation of numbers 1 2 3. So for 1 it is 1, for 2 it is 1 0, for 3 it is 1 1. Okay, we have found the binary representation of numbers. We concatenate them. So this would be the for 1 2 and 3. We concatenate their binary representation, and we have to find its decimal value. Okay, and its decimal value would be, we can easily find it would be 27. Okay, so we have to return this particular value. So it seems to be a very easy question, so let us try. So our first approach, what we can say is a naive approach. So what we do here, we do as the same asked in question. Okay, we form a string using the binary representation of the number 1 to n. So suppose we are given the number as 5. So we take a string that would be empty, and we would use a loop that would be from 1 to the given number n. So here the given number is 5. So we have a loop from 1 to 5. This binary representation function, in which we pass the number, and it will give us the binary representation in form of the string. So this function will give us the binary representation of the number. So this function is written here. So what we will do, once we received the number as the parameter, we take the modulo of the number. That is basically, if the number is, let's suppose n is equals to 4. So we take n mod 2. So it would be 0. We push it into our answer, and we divide the number by 2. So now it would become 2. Again, we repeat the same thing. We take its mod by 2. We again get 0. We again get 0, and we divide the number by 2. We are getting now number as 1. We again take 1 mod 2. It would be 1. And again we do 1 divided by 2. Now n would become 0, and at 0 we are applying a termination condition, and after that we'll reverse this particular string. It would be 100. So this is the binary representation of 4, and we will return it in the form of string. Here we receive this particular string. Okay, here we receive this particular string, and now what we will do, we concatenate it. We concatenate it in our larger string that we are taking, and now when we obtain our bigger string, so for 1 2 3 4, we have find the binary representation, we have concatenated it. So this is the number, this is the representation, the string representation, which will form after concatenating. So we'll find its value. So we'll find its value, we can easily find its value. So it would be something 2 plus 2 raised to power 0. So we can easily find it by using the base 2 method. So at this position we would be having 2 raised to power 0. At this position we are having 0 into 2 raised to power 1 plus 1 into 2 raised to power 2. This sort of things. Okay, now this is done, but this will result as a larger value that will exceed the limit of integer. So we are applying mod here as per given in the question. We are applying mod here 10 raised to power 9 plus 7, so that it would remain inside the integer range. Okay, so this approach is good, but it requires more time complexity and space complexity to store the string representation firstly, and to compute the string representation for each of the number from 1 to n. Okay, so string concatenation requires a lot of time and extra space, so we need to think something else. So now we look at the second approach to solve the problem. Okay, so let us consider the similar case where we are given n equals to 5. So we have to concatenate the binary representation of number 1 to 5. Okay, so initially I have written the binary representation of the individual numbers. For 1 I have written 2, 3, 4 and 5. Okay, at each step the concatenation is what the concatenation will look like. We would be having 1, then this 2 would be concatenated, then this 3 would be concatenated, this 4 would be concatenated, and this 5 would be concatenated. Now what is the scenario here? Whenever, let's suppose we are having 1, initially we would be having 1. Okay, so if 2 is concatenated with 1, this particular bit, this one bit is shifted by number of digits, number of binary digits in the number 2. So these are 2. So it is shifted, the bit 1 is shifted to its right position by 2 steps. Okay, so here 1 is shifted by 2 steps, and this will be added to the answer. Okay, now for 3, what will be the case? These bit, that is basically 110 110, are shifted towards the right by the number of digit position, that is 2 position. So these will be shifted 2 position to its right, 2 position to its right, and we will add this particular value. Okay, now for with 4 the similar case will happen. These bits will be shifted the number of digit position to its right, and we will add the corresponding value. Okay, for 5 the similar case will happen. The previous case, bits will be shifted to its right by the number of digits of this particular value. So I have written it here. So initially it would be having 1. So 1 would be shifted 2 position. 2 position are the number of bits in 2. So these are shifted 2 position to its right, and we have added 2 here. So now its value has become 6. Now for this 6 will be shifted towards its right, the number of position we have in this 3. The number of bits we have here are 2. So this 6 will be shifted 2 bits towards its right, and we will add 3 to it, and we will get 27. Now this 27 will be shifted to the number of binary bits in the number 4. So we have 3 3 bytes in 4. So 27 will be shifted 2 position to its right, and we'll add 4 to it. We'll get 220. Now this 220 will be shifted the number of digits, binary digits, and 5. So it will be shifted to 3 position, and we'll add 5 to it. So we will be getting 1765. Okay, so this is the explanation of the logic, and now I will show you the code. So at each step what we are doing, if we are at number one, we would be finding the number of digits in its binary representation. Okay, we will find the number of digits in its binary representation. So here we have, for 1 we are having only 1. Okay, so j would be 1 here. So initially answer would be 0. So if we shift 0 bit to any number of times, so it will remain 0. So 0 plus 1, answer on the first case will remain 1. For the second case, when I become equals to 2, I become equals to 2, then number of bits are 2. So j become 2. So the answer bit will be shifted 2 position to its right. So if we shift 1 by 2, it would become 4, plus we would add this particular I also. So we would be having 6. So for this particular value, the answer would become 6. Okay, so I would write it here. So answer had become 6. Now I will become 3, J will become 2, the number of digits in its binary representation. So this answer will be shifted, this answer bit will be shifted 2 position to its right. Okay, 2 position to its right, and we will add I to it. So 6 into 2 to the power 2 plus 2. So it would be, sorry, 2 to 3. So we would be adding I na. So we would be having 27 here. So the current value of answer would become 27. So for the next case, I equals to 4. So we are considering the case when n is given as 5. Okay. When I equals to 4, we calculate the digit. There would be 3. So this 27 will be shifted towards its right 3 bits, and we'll add 4 to it. So it would be 27 into 2 to the power 3 plus 4, it would be 220. Okay. So for the next answer would be 220, I would be 5, J would be 3. Okay. So for 5, the binary representation is this. Okay. So we are having 3 digits. So 220 will shift towards its right by 3 bits, and we'll add I to it. So 220 into 2 to the power 3 plus 5 will give us 765. And this is the code. We are having answer. It would be, there would be a loop running from I equals to 1 to n. For each value of I, we calculate the binary digits. We shift that number of bit times towards its left, take the mode of it, and add I to it, and take the whole mode. And at the end, we'll return the answer. So this particular approach requires the time complexity of order of n, and we are not requiring any space. Okay. So yeah, these are the approaches to solve the problem: concatenation of the consecutive binary representation. So if you have any doubt, please feel free to ask, and bye.